Hey physics, this is Mr. Hausman. We're going to look at a Coulombs law problem like we tried the other day, but we're going to do it kind of from a review standpoint. So let's face this challenge. We have two charges. We've got a Q1 and we've got a Q2. There are so many different ways these could become charged. Maybe they were in a physics lab, maybe they were balloons. Remember the story about the balloons rubbing against the elephant? These two charges could even be things like styrofoam pellets that both get a charge. Now, in this case, we're trying to find how much force is repelling these two charges. So how would I know that they're repelling? Well, I notice right over here that Q1 is positive and Q2 is positive. So we know that positives repel positives. But the question is, how much force do they experience? And that can be easily done with Coulomb's law. The force, or the electric force, is equal to K, which is a constant, times Q1, the charge of the first balloon, times the charge of the second balloon in this picture, divided by the distance between them. That has to be squared. So fundamentally, we're just multiplying three numbers on the top and dividing by a fourth number squared. But as we know, there are some challenges. The K value is 9 times 10 to the ninth. We can put that into scientific notation using our calculator, and we'll multiply it by 4 times 10 to the negative sixth coulombs. Keep going on your calculator and set it up with Q2, 7 times 10 to the negative sixth coulombs, and divide that by 0.2 meters, quantity squared. So you take out your calculator, and let's simplify the numerator. I got a numerator equal to 0.252. Then the denominator is a little bit easier to simplify because I just have to square, which means multiply 0.2 by itself, or use the squared button, the x squared button on your calculator. And that should come out to be 0.04. That looks pretty easy to simplify. And so we'll finish this problem with a pretty straightforward calculation of 0.252 divided by 0.004, or a force of 63 newtons. So let's interpret that. That's not a huge force, that's not a small force, but it's pretty significant, and it would be both the magnitude of the force to the right, how hard does Q1 repel Q2, but that's also the same amount of force that Q2 pushes on Q1. So we've got a final answer of 63 newtons is the mutual repulsion between the two. So now you're going to try another. Let's see how well you can do.